Okay, so welcome to this video. So we're going to discuss about fuzzing JavaScript WebAssembly APIs using Dharma specifically, and we're going to target the V8 engine, so that's the JavaScript engine used by Chrome typically. So I will be quick on the first part and on all the more generic stuff. So I will let you take a look at that, and I'm gonna be more focused about like the command line and how to get the stuff working. So okay, let's start. So first of all, WebAssembly and web browser. So WebAssembly is supported by a lot of different web browsers, like all the major web browsers on both desktop and mobile. So I invite you to take a look at caniuse.com, this specific link, because it will point you to this tab, and you will see which version of each web browser is compatible with WebAssembly. So that's the idea. So the main goal of today is to generate some JavaScript file that will call those WebAssembly JavaScript APIs. So there is a bunch of them in terms of WebAssembly JavaScript APIs, like WebAssembly instantiate, compile, validate, global, and so on and so on. So all those ones are defined officially by the W3C foundation, if I remember. So it's like a standard, so that's the good part of it. And since it's a standard, it will be the same for all the other web browsers that are compatible. Okay, so the first point is how to create a Dharma. So just to mention quickly, Dharma is a generation-based fuzzer. So the main idea is you provide a grammar to Dharma, and Dharma will be able, based on the grammar, to automatically generate some file that match this grammar. So it's a really nice tool, one of my favorites. It's kind of similar to Domato for people that know Domato. Domato is like an equivalent, but developed by Project Zero, and Dharma was developed by Mozilla, the Mozilla security team. So I really like Dharma, and typically the grammar will look like that. You are defining some possible value. Like for this wasm type int, it could be either a string integer 32 or the string integer 64, and so on and so on. So you define this bunch of grammar and dependencies between those different type and possible value. And once you've done that, you can generate some JavaScript file using this command line. So let me show you that right there. So I also provide this file, the install sheet sheet. So you have all the command line to start. To install Dharma, I will invite you first to git clone. It's not mandatory, but it's I think it's better because at least you will directly get this grammar. At least, I mean, specifically because I create this grammar and I push this grammar into the Dharma repository, the official repository of Dharma. So that means if you do the git clone of the Dharma repository, you will already get this grammar that will be provided for you. So that's exactly what I've done right there. So let's go into Dharma, and what you can see is Dharma grammar, and there is the wasm.dg, okay, and that's the one. So let me open that right there. Okay, so that's this one. Let's color that with Python, and as you can see, author Patrick Montizello, so it's me, and yeah, there is some links and some description, and you have the complete grammar. It's a tiny noise. It's really like an introduction and like one of the most basic grammar you can have for WebAssembly JavaScript API, but it's a really good start if you want to start playing with WebAssembly and Dharma in general. So you install Dharma, and after that you can directly execute Dharma and generate some file. So that's what I've done in the output folder. So let me show you the content. So as you can see, there is 100 files right there. Don't take care of that. It was like a test. So let me remove that. But at least I will remove the complete stuff. So output folder, rm-rf. Okay, we are good. So right now what I want to do is to generate some Dharma files. So as I mentioned, I can just copy paste this stuff. At least on my system, I will need to do a Python 3-m Dharma grammars. So this command line right there, Python 3-m Dharma grammars. I provide the grammar, that is wasmdg. The count, the number of files I want to generate, so 100. The format, so it will be the extension at the end of the file. A specific seed in order to get all my files to be reproducible. And some, oh, let me just remove that, it will be better. So we have, as I mentioned, the grammar, the count, the JavaScript extension, a specific seed, and after that, the folder you want to output all of your stuff. Okay, let me remove that. Okay, good. So as you can see, Dharma is running and it's already done. Let's see how many files we have. Yeah, we have 100 files. So you can actually take a look at what will be inside. So let's see output folder like the 11 one, and you can see that Dharma automatically generates some JavaScript file. So all those parts is like the initialization of some variable. So right there, and after that you have the call to let me put that right there. Okay, and you have a bunch of calls that have been generated automatically. So that's pretty nice and pretty efficient, and as you can see, it's pretty fast as well. Okay, so right now we have a bunch of JavaScript files. So the next step will be to provide that to a web browser. So first of all, we will need to download a web browser, and I will discuss that right now. So I mentioned that we're going to target V8, the V8 engine, and specifically we're going to target the V8 ASAN address sanitizer build. So address sanitizer is a tool. It's a memory error detector. Sorry, and when you compile like Chrome or V8 with address sanitizer, at runtime, address sanitizer will verify that there is no memory issue that is happening during the execution. That's typically address sanitizer that is able to find a bunch of vulnerability, like in-depth vulnerability, like use after free and stuff like that. It's because of him. So that's really nice to compile your engine and your program in general with address sanitizer, especially when you are dealing with like C++ code, because it's way less secure than something like Rust, for example. So the good part with that is Google already provide already compiled version of Chrome V8 with address sanitizer, and in order to download this package, you need to use a gsutil. So I provide you the command line right there. That's for the gsutil installation, and after that you just need to say gcloud init, and that's pretty much all. After that you can download the Chrome V8 build with ASAN using this command line. So this command line, the first one, will retrieve the last version of like the name of the last version of Chrome V8, and after that you provide that to a gsutil copy, and you will download that locally. So it will be around like 3.5 4 GB, I think. At the end, you will get something like that. Let me show you V8. You will get like a big zip file, and if you unzip it, you will get all those files. So let me remove that. We have in this folder, you will get a bunch of stuff, especially the most important stuff for us will be D8. So I mentioned, so we have Chrome, that is the web browser. Inside Chrome, we have V8, that is the JavaScript engine. And actually, Google also provides D8. And D8 is like a command line shell, command line binary to interact with V8 directly. So for us, it's pretty nice because if we take a look at Chrome is like a 2.2 GB. Okay. If we take a look at D8 will be 164 megabytes. So definitely not the same size, and we can provide JavaScript file to D8. So let's give a try. D8. If we are doing that, we have like a shell. We can say, okay, I just put like the L stuff, and we can see like a JavaScript error, reference error, L is not defined. So that's the JavaScript error. So let's quit that. Okay, so we have D8. D8 is able to run and execute JavaScript file. So let's give a try. We have we just compile and generate some file, not compile but generate some file previously in the output folder, the file 11, and we can say D8 11, and as you can see, there is no error, no information. It's because in the file we have seen previously, the 11.gs, that is right there, like this one, we are using a try and catch before every operation in JavaScript. So in these cases, we are sure that the execution of this file will not generate some error, but error like developer error, like error due to bad JavaScript. What we are looking for is vulnerability and error in the JavaScript engine itself. So that's the idea. So we are now able to provide this JavaScript file to D8, and it's kind of pretty efficient and pretty simple in that way. So last step for us is to automate all of that. So you can of course create like a basic bash script and just provide all the files you have generated to D8 and monitor for the exit code. That's something possible. You can also create like a Python script that will maybe use multi-threading and run multiple like execute this binary with like a given input in parallel. That's something possible, but I'm kind of lazy, and I really like this technique, at least for testing like that, and it could be something you can use in the future. I'm using Honggfuzz. So Honggfuzz is really easy to use fuzzer. For the one that don't know Honggfuzz, it's kind of similar than AFL. Personally, I really prefer Honggfuzz than AFL. And the main reason for that is Honggfuzz will directly handle multi-threading, and it will also provide a bunch of tools and stuff in addition to the tool itself. You can also use different methodology and techniques to get feedbacks and so on. So for me, Honggfuzz is definitely one of the best, and it's well maintained. In case of AFL, you have AFL++ if you want to give a try, and I'm pretty sure you can do something similar than that, but for me, Honggfuzz is the best way to go. So I provide you this command line. It's nothing really fancy there. The main idea is we are telling to Honggfuzz, okay, please just generate multiple thread with a timeout of 5. The input folder is this one, so you can grab all the file in this folder, and you have -- and you provide the command line. So we are running D8, and we have ___ file and 3__, and Honggfuzz will directly replace this pattern by the input file that you provide. So I already, so let me check. I think I already use Honggfuzz. Oh yeah, for the compilation of Honggfuzz, I forgot. You are just doing like a git clone and make, and at the end you will get Honggfuzz right there, and you get the Honggfuzz binary right there. Okay, so it's working well, and we can just give a try, and we get the helper of Honggfuzz. So as I mentioned, what I want to do is to run Honggfuzz and with the provided folder. So let's see if I got, yeah, perfect, I got the stuff. So I was on the V8 folder for this command line. So I'm on the V8 folder, I'm running Honggfuzz. So let's verify Honggfuzz is there. Yeah, good. Okay, yeah, perfect. So we have Honggfuzz. As I mentioned, you can put some stuff, some argument there, but it's not mandatory. After that, we provide the input folder that would be Dharma output folder, and -- and we provide the path to D8 and the specific pattern, the file keyword for Honggfuzz. Okay, so let's run that, and what you will see is Honggfuzz is starting. We are on the feedback driven dry run, so Honggfuzz will take all the files inside this the folder you provide, and it will first just run them without any modification, just run them. So that's exactly what we want. And actually you can see that it switched to the feedback driven mode, so we can actually stop the fuzzer, because in that cases it will try to get some feedback from the binary, but I mean, the binary is not compiled with any feedback instrumentation code, so it doesn't make sense to keep it working. And also it will try to do a mutation fuzzing on that, and a mutation fuzzing on JavaScript file is kind of complicated, and Honggfuzz and the mutation algorithm of Honggfuzz are definitely not suitable for that. So it doesn't make really sense to do it. So that's why when I say it's kind of the lazy way, it's really if you generate like thousands of files with Dharma, you can after that just provide them to Honggfuzz, and I mean, that's the lazy way. Okay. Okay, so congrats, you are now able to go through all the blog posts by yourself and reproduce what is there. If you need, if you have any question, you can put that on the there is a comment section below, I think, on this courses like interfaces, so you can use that, and yeah, let me know if you have any question, and I will be happy to help you. Thank you.